Okay guys, today's video is going to be on creating a couple tools to help you troubleshoot a BK M150 mobile. It's got a remote head to it, and just want to start off with a lot of times when you are troubleshooting and you have the radio in a really bad place and it's really hard to get to, it's really helpful if you had some way that you could half split the problem and see if it's either the head or microphone or if it's the radio itself, and a lot of times that's not very easy to do. So I'm going to show you a couple tools that you can use and how to go about doing that. Right now I have a typical mobile mocked up on the bench here. It's got your control head with the speaker coming off the control head and your remote cable here going over to the mobile, and it's all standard operation as far as that's concerned. If I was to transmit here, I'm on the weather channel, so it's a receive only. And if you do try and transmit, you get a nasty little warning and tell you that it's a receive only. But we're going to use that to our advantage here in just a sec. I'll show you how. But to start off with, the first tool I'm going to use is really easy to make. It's just going to be a DB9 female and a DB9 male on the other end, and it's going to be inserted in line with the control cable. And what this does is it takes the transmit audio that's coming out of the head and loops it back into the receive, and you can essentially make your own little PA system there, and I'll show you how that works. All you have to do is remove the control cable, and you see on a remote head when you do that, it powers down because it relies on the main radio to provide power control to the remote head. And when I hook it back up, it'll put a ground back on it, and we'll allow it to boot back up, and we'll see it comes back up, and it's all back to nice and fine again. This time, however, when I go to speak on the mic, because I have the audio that's coming from the radio to the head disconnected, and it doesn't know not to send its transmit audio out, and the two levels are matched. They're the same levels, which makes it super convenient. So this is what you end up getting. Testing 1 2 3 4, 1 2 3 4, and you have like the perfect PA system, and you can really test your microphone and get a real dynamic, super clear response. And you can establish, like, okay, at max volume I can get this far away before I start feeding back. Unfortunately, we have a problem with these particular microphones in that they can go kind of muted. They'll give you like a half or a third deviation or even less. It's clear audio, but the level is just way down. It's got some issues in it. I even found one that's it would be perfectly fine, great audio, until you tighten the last screw, and that's when the audio would go down. So you do have a fair amount of buggy microphones, and the other biggest problem with the microphones are that the pins inside the mic connector retract back into the cord, so they don't fully insert into the connection, and you lose your connection there. But anyway, this is, like I said, the first tool. Testing 1 2 3 4. It makes it really convenient. Now you can take your speaker and microphone and move it over to your other side. If everything tests good here, you're looped back on this direction as well, so that when you do the test over here, if there's any problem with the control cable path for the audio, you'll find it there. If you put it on this side and you have trouble with it there, take the little extension insert and relocate it to the other side if you can. But I don't, the miniature DB9 connectors on the mobile are really hard to deal with, and so I hope not to have to cross that bridge and do some kind of adapter for those, but that's why I'm just sticking with the front head right now. So anyway, this is the first tool that I have to use to help confirm the mic and speaker operation up here is good. I'll show you the next tool that I developed, and I it came by accident because I was in the process of troubleshooting a dead radio and trying to figure out how the radios power up. What is the sequence? What wires go to where, and how does the on-off switch work? And they're slightly different on the main radio and the control head. Bottom line is that the main radio can boot up and turn on by itself. The head here has to have permission from this unit in order to boot up, and it's just a simple ground on one of the pins on the DB9 there, but I'll get to that in just a minute. But first, let me give you a little background on the next tool that I came up with, and show you how that came to be. I'm going to reposition the camera here so you can see the next setup. And alrighty, and so here we are. What I'm showing here is I'm showing a dash mount mobile, and next to it is the remote head, and they're just kind of disassembled in 3 parts here to show you the basic outline of how they work. Now I'll start up here with the dash mount. The turn-on process with the dash mount starts with the main B plus coming in here on your main power. It comes on the RF board, has a current limiting resistor on one of the pins that comes out here, and this goes back into this pin 7, and this 12 volts then goes through the RF board, then goes through the interface board here, your options interface board, through the flex connectors, and then into your main, I'll call it the main brains, the microprocessor, all the smarts section, the head here. It more or less turns on a little transistor that provides a ground to the on-off switch, and when you engage the on-off switch, it strobes a ground connection over to the microprocessor that's laying dormant, and as soon as it sees that ground, it fires up and starts all the boot up procedures. Now on the remote mount, it's different. It can't, like I said, it can't boot up on its own. Its power is given to it from the main radio. Now it can request a turn off and it can request a turn on, but this radio actually controls this head, and it does so by one of the lines on the DB9 connector here, that when the mobile thinks it's okay for the head to turn on, it'll put a ground on there, and this allows the head to boot up, and it gets its little sequence of it it's going to start up. Anyway, when you look at side by side the heads and look at them, they are essentially identical. And when you go to the schematics and look at what they say in the schematics, you find that they share a common schematic, and they just have notes of saying, okay, this head has a jumper here, but this one does not. And apparently, it's just a couple jumpers that make the difference of whether it's a radio full-blown head or just a dummy head. The full-blown head retains all the memory for all the channels and all the features and everything about it. The remote head, it is a complete dummy. It doesn't even generate its own audio internal to itself. It relies on the mobile to give it all its audio. Even button change audio comes from the main radio unit, not from this head. It has its own audio amplifier to drive the speaker, but the source audio comes on the DB9 connector from the radio. Now, mechanically, they appear to be identical as well. And when you look at, well, how hard would it be, what would be involved if I took a radio head that's got all the intelligence and put a remote chassis on it? What would happen? Would it turn on? Well, it just so happens that on the ignition sense on a remote head, that's not enabled. So that pin 21 on your DB25 connector goes to nowhere. It's a dead-end connection. However, on the DB9 connector, you essentially have the same function, except it's changed polarity. So that if you put a ground on pin 8 on the DB9, then the head comes on. And remarkable as it seems, when it comes on, it doesn't seem to notice that it doesn't have a radio attached to it, or at least an complete RF section. I saw that and I was completely blown away. And then I was like, well, hey, if we could do something like that, I bet you anything, it would still talk to the remote, because there was nothing preventing it from doing that. So let me show you what I came up with, and let's put it in action here. Excuse me. This is what it looks like. I call it the radioless radio. So the entire smarts and everything is inside here. So let's fire it up and I'll show you how you can use it to troubleshoot a remote. Alright, let me reposition the camera. Steady. There we go. Alright. So, I had a way of testing the audio on the mic and speaker at the local head, but I really wish I had a way where I didn't need the radio on the other end in order to do it. I wanted to be able to see if I could really find out if everything worked right. And this is where this idea comes in. So let me show you how it works. I will unplug power here from the head, and we don't need this radio anymore. We can put it to the side, and now we're going to bring in the new radio. So let's first get this one fired up, and I'll show you how it comes on completely all by itself with no issues, and everything's there, and it has no idea that there's not a radio attached to it. Now if you hook up a mic and key on it, it'll immediately give you a synthesizer fail alarm, but until you do that, it's happy as a clam. You can actually do all the normal things that you would do with a radio. You can read it, program it. You can clone other radios with it, so you could take this around as a clone source. But right now we're going to use it to troubleshoot this head. So I'll go ahead and turn it off and take the little shorting plug on the back, which is all you need for it to fire up. And I'll go ahead and attach its proper cable when you're hooking up to a remote. Now, on this cable here, I have the same pin 8 to 4 short here to give you the turn on capability. And I've done the same on this end on the remote as well. So let's get them all plugged together. And now let's share power. And even at full volume, when you're testing these, it doesn't draw but maybe no more than 2 amps at the most. You can barely see the thing register there. But let's fire it up. And boom, and there you go. You have the dual control heads with no radio. And you got all the normal operation here. And once again, I'm on a receive only channel. I have my loop back in here. So now I can once again test my PA system. Test 1 2 3 4, 1 2 3 4, 1 2 3 4. And you see I receive only when I'm transmitting, but that still allows the audio to come in because it needs to play that tone, so I'm kind of faking it out this way. But in doing this, what I've done is I've completely eliminated the mobile radio, and I'm able to completely test this head unit right at the head. I know everything about it works because if there was anything else wrong with it, it wouldn't talk to this radio just like it wouldn't talk to this one. So you do all your connections here, you do your test, everything seems to work. You get back, you hook up your main radio and you're still having problems. Well, at that point, you're pretty much guaranteed you got a control cable issue, or you have an interface issue where the control cable plugs in somewhere inside your main radio. But this allows you to do all the work on the head without getting down into the where the radio is, because like I said, that can be a lot easier said than done, especially in some bulldozers and things where these radios are in some really bad places, and it's a nightmare trying to take them out of the brackets to get access to the cabling. Some of these really bad design on the mobile bracket here. They're really difficult in tight locations. So anyway, here's your like I said, here's your radioless radio, and I've tested the cloning and everything, and it works good. You can also give you the ability to go ahead and upgrade your firmware without having to mess with the other radio as well for your head. But there it is. That's hopefully between the simple loopback cable. If that's all you do, that's fine. Or you do the full radio in the head. They'll both really help you out. The last thing I did want to show before I ended the video, just wanted to pull it out and give a visual for you, is this is my DB9, excuse me, this is my DB9 breakout thing that I made, and it just allows me to get in between a DB9 connection and look at each individual sets of wires individually and open them up to look at what's on either side, who's in control of the circuit, and to find out, well, what happens if I lose this wire, what does it do, etc., etc. Very handy thing, good troubleshooting tool as well. So wanted to throw that in. And all right, hope that all helps for you guys. We'll talk to you soon.